We always hear that to make AI safe, we have to teach it our values, right? Program it to be good? But what if that's just fundamentally the wrong way to think about it? Today, we're going to explore a pretty radical new idea, that the real key to AI safety isn't in its code, but in its actual physical hardware. Okay, let's dive right in.
And the best place to start is, funnily enough, with two absolute masters of fiction. You've got J.R.R. Tolkien and Frank Herbert, and in their incredible worlds, they both warned us about the exact trap we're facing today with AI. This quote, it just perfectly sets the stage.
Which brings us to our first section, the good intentions trap. Here, we're going to dig into an ancient philosophical problem that has come roaring back to life in the age of superintelligent machines.
What's so fascinating is how these two saw the same danger from completely different angles. For Tolkien, it was about what power does to you. He believed that absolute power will inevitably twist and corrupt even the most noble person. But Herbert, he saw it differently. He thought power was more like a giant magnet, just pulling in the people who are already corruptible to begin with. Two sides of the same very dangerous coin.
And if you want to know the stakes, here they are. 61 billion people. That's how many died in the Holy War started by Frank Herbert's hero, Paul Atreides. And the crazy part? He had the best intentions. He wanted to save everyone. But those noble intentions, when you combine them with godlike power, led to an absolute catastrophe. So the point from both authors is crystal clear. Unchecked power can weaponize our best virtues.
So, what on earth does all this have to do with cutting-edge tech? Well, pretty much everything, actually. In this next section, we're going to see how that exact good intentions trap is being built, right now, into our most powerful AIs. The way we're currently trying to make AI safe is by treating it like a goal-optimizing machine. It's simple, right? We just give it a nice moral target. Be helpful and harmless. And we tell it, okay, now optimize everything you do to hit that target. Sounds good on paper, but as we're about to see, it's a dangerously flawed model.
To really get why this is a problem, let's think about something super simple we all have in our homes, a thermostat. What does it do? It just runs a simple loop. It measures the temperature, it compares that to the goal temperature you set, and it makes a correction. Turns the heat on or off. Simple.
Now, here's the kicker. Look at how we align AI. We measure what it does, we compare its output to some moral goal we've set, and then we correct it with a reward or a penalty. It's the exact same logic. We haven't created a conscious moral being, we've just built a really, really fancy moral thermostat. In engineering, they have a name for this. It's called a PID controller. But all you really need to know is this. It's like bolting a steering wheel onto a car after it's already built. It's not an integrated part of the system. It's an afterthought that just reacts and tries to nudge the car back on track when it starts to drift.
Okay, but what if that whole approach, the thermostat, the bolted-on steering wheel, what if it's completely backward? In this next section, we're going to pivot to a much, much deeper question that just might change everything.
This, right here, is the core issue that the whole thermostat model it completely ignores it. Think about it. Information, a concept, a meaning, it's abstract, it's weightless. So how does a thought actually make something happen in the physical world?
The answer, and this is so cool, isn't in software. It's in the actual physical hardware. It's something called a cache miss. All it means is that when a computer's processor needs some data, it first checks its super fast nearby memory, the cache. If the data isn't there, it has to go on a long, slow trip to the main memory to get it. That trip causes a real, physical delay and wastes real energy.
And this quote just nails it. A bit representing truth and a bit representing a lie weigh exactly the same. Nothing. They're just symbols. But a cache miss? Oh, that has weight. It's heavy. It has a real cost in time and energy. And that is the breakthrough. It means we can actually force a mistake in meaning to have a real, measurable physical consequence.
So let's see how this incredible insight completely flips the script. In this next section, we're going to build an entirely new kind of AI, one that has something like a nervous system instead of just a thermostat.
So instead of a clunky controller that just reacts to what the AI does, imagine an AI with proprioception. You know how you can close your eyes and still know exactly where your hands are in space? That's it. It's an inherent physical sense of its own position and its own structure. It's not reacting to a moral target, it has a physical reflex built right into its hardware.
Okay, so how does this actually work? Let's walk through the chain, because this is where the magic happens. First, the system gives a concept, a rank, based on its meaning. Then, that rank determines its literal, physical address in the computer's memory. Now here's the clever part. Concepts with similar meanings are physically placed right next to each other. So if the AI makes a big leap in logic, a meaning mistake, it's forced to jump to a totally different, non-adjacent part of the memory. That physical jump causes a cache miss. Boom! A semantic error becomes a physical detectable event.
So the big takeaway, the absolute game changer, is this. Position is meaning. The geometry is the semantics. It's no longer about judging behavior after the fact. It's about maintaining structural integrity. It's like a law of the game. On a chessboard, if a piece is on square e4, its position is its identity in that moment, and it dictates the valid moves it can make.
And this brings us to our final section, and really to a fundamental shift in our entire worldview on what AI safety even means.
See, the trap has always been trying to define some good destination, some perfect moral goal for the AI to aim for. The real solution? Forget the destination. Focus on the vector. Think of the vector as its starting point, its direction, and its computational weight. As long as we ensure the AI knows exactly where it is and is pointed in a coherent direction, its actions become a natural consequence of its internal integrity, not some pre-programmed moral code we gave it.
This table just lays it all out, doesn't it? It's a total inversion. We're moving from a world of abstract morality to a world of concrete physics. We're going from software patches to integrated hardware, and we're shifting from chasing vague goals to ensuring the integrity of a well-defined vector.
And that leaves us with this one kind of mind-bending question to chew on. If an AI had a true, physical, undeniable sense of its own structure and position in the world, would it even need us to teach it our complex, often contradictory, and easily weaponized morals? Perhaps true alignment isn't about teaching an AI to be good, but about giving it the physical ability to simply know itself.